What am I using? Okay, not return.
Mr. Sylvester. Hello.
What's up, Ms. Bradford? How you doing?
Good. I didn't do that. I didn't understand the home sign. I couldn't do it.
Huh?
I was confused.
No, listen. And I looked at some of the comments some people sent. Now, and well, I guess I'll wait till everybody get on.
Okay.
Because one thing is, and I'll be trying to tell you, understand the concept. Now, and what I mean by that is, we went over many different aspects of pointers, correct?
Yeah.
But I only picked out 2 for you to use for one to use for one program and one to use for the others. You didn't have to go in and create a pointer variable. You didn't have to do none of that. If you looked at the program we looked at the example, and I think even we wrote one where we read the information and we did the plus to keep going and printing it out. That's all you have to do for your input and your input and your output. I just wanted you to get in your head that you can manipulate it. There's many different type programs I could give you, but there's not enough time to write programs for all, you understand? With all the different type of features. So basically, let me do this. All right. Which one I'm in? I think it's this one. Let me go back here. All right. So really, all you had to do for one, like I say, I showed you how you can point to a variable. That wasn't a part of the program. Showed you how you could dereference it and print it. All right, getting you up to where you can use this. So look at this. When you see this, that's just like, what's this? The same as writing. How would I write this in the subscript? Numbers is the array. How would I write this? Rewrite this as the array with a subscript. Numbers is the array. How would I try if I was said see out numbers, but I want to output whatever this is representing? How would I output it? See out what?
See out num, huh?
No, see out numbers. The square brackets 1. See, this represents that second position in your array. Number sub 1. This represents the third position, number sub 2. If I would have 0 here, it would be the first element, number sub 0.
Are you showing me something?
Oh yes, I am. I thought I was. Yeah, excuse me. That's my fault. Let me share my screen. All right. Okay. Oh well. Okay. Yeah. All right. So now, yeah, this is what I was looking at. So when you look at this, numbers is an array. Okay. So if I wanted just to rewrite whatever this represents out with a subscript, how would I represent it? Numbers,
the brackets.
Right, 1.
Right.
Because that's what this points to, that address of the second element. Mm-hmm. You understand what I'm saying? So yeah. All you had to do for that second program, the first program, you took it and you did the like numbers plus. You got me? And keep incrementing. And for this one, for the second one, all you had to do was numbers plus one, but you had to do the dereference. So if you say we let's look at this. So say, and I'm not going, God, what I have here? All these blank lines, I must have been holding on the keyboard, holding the inner key down. Okay. All right. All right. Well, here I go. So, okay, so I have this. So say I had an array. So I had int, I'll say I'll give it numbers, and I'll say 10 is equal to all right. And another thing, you were supposed to use the same program, the program with the arrays in it, not the vectors, right? So Simon say using the previous program dealing with arrays. All right. So now, so if I want, I could do something like say for. I know I got 10. All right. What I could do, I could do a C out, what it is, C out, and I'll say the array, not in, numbers plus plus, all right? So, plus plus numbers plus plus is the point. Let's see something. Oh, S. No, numbers. Where am I? Plus plus numbers plus plus.
So it wouldn't be int times variable?
No, but that's the second one. See, the second would be the plus X. You understand? That would print that one. So what happened when it's 0, and I'll do it in line. You understand? And so rather than me manipulating this with
and it wouldn't be that Apperman that that
you don't do the ampersand gonna give you the address. You want the value.
Okay. Woo.
Yeah, you want the value. All right, and then that doesn't go into this expression here. So what happens is now I can do the debug. I might have to. Okay, it's gonna ask me. See what I'm saying? Yeah. So and then I can still do the same thing. I could do what I'll do here. I'll just do this here, and I'll print out the exact same thing, but I'll use number sub X. All right, or not numbers. And what should I get? When I print numbers of X and dereference into this, and I print num sub X, what should be printed here and what should be printed here?
It should be 0, huh?
No, this is the equivalent to this. When X is 0, I'm printing num plus 0, numbers plus 0, dereference that value, give me the value. And here I'm printing number sub X, which is the 0 position. You understand? And it's going to give me the value. So I'm going to get 10, 10, 20, 20 every time through. So this is how you wrote the program the first time. Why you want when you read the information in?
Yeah.
And this is how I wanted you to write it. You got what I'm saying? So when we look at this,
you can do the array plus plus if you just dereference
Right.
numbers, and then after you do it, goes to the next line, and then put numbers plus plus.
right? Okay, yeah. So you talking about if I do the plus plus?
Right. Yeah. If you just dereference numbers, and then go to the next line after that, and then
Right, and do numbers plus plus. But yeah, because you're right. So what you're saying, if I do dereference numbers,
right. So you do C out, and then stream dereference numbers, stream again, then do quotation marks. You can do
right.
semicolon,
But see
next
what
line, numbers plus plus.
right.
We don't have to do. Wait, I'm wait.
No,
go
but what he's saying is the two different ways I ask you to do it.
Okay.
Because just dereferencing numbers, that's gonna give me the value at numbers, right? And then if I do numbers plus plus every time through,
That moves the address.
to the next position. So this is doing the same thing this doing. Oh, what happened here? Oh, the semicolon. Or whatever. Right. So what happened? Why they give me this? Why am I getting the error? It's saying expression must be a modifiable variable, but that's numbers. Numbers plus plus, it should be right. Numbers. Semicolon here. I'm getting a dereference value. I'm incrementing here. Why?
Did you declare a pointer? Or
No, but numbers is the
is an
array.
array?
Right. Numbers is the array. Why is it doing that? Yeah, because every time I increment, because remember we saw the program that we ran? Did we in the example, remember in our where was it? It was toward the end. Here, see here? ARR, well, we passed it. But still we passed what? Well, we didn't we used the dereference where we print, and all we had to do was increment the ARR, which was the array that was passed to the function. I'm wondering why. See what's going on.
Do you think it's because the parameters or the arguments are?
No, because no matter where it is, see, this only gonna give me the sub-zero. This gonna give me sub-zero the first time through. This gonna give me the sub-zero, the address, because it's at what? Numbers. And we still at what? Sub-zero.
Right.
This should increment by 1. So when we go here, it should do x sub 1, well, do the 1, so num sub 1. I'm wondering, I got see out this. Because if I take this out, it's gonna only give me num sub 0, 10 all the time. I don't know what's going on. Let me run it. And see, I'm gonna get 10 times. See, I got 10 different times. That's not what I want. See here, I got it printed 10, 10, but then 10, 20, 20, but then 10, 30, 30, which is the first line, and then it's staying stuck on 10. So numbers plus plus. NUMBER, that's right. That should work. And it's telling me Expression would be a modified value, I value. No, I shouldn't have to. Oh, no.
Maybe it's not recognizing the numbers as.
Cause see, I'm trying. That's the address. But it's a pointer because what? Look here. It's an array. But let's look back at this. Where's ARR here? But ARR is it is actually the well, this is a pointer, but still, I should be able to do the array. But let's see, because when I double the array, when I add to the array, I'm actually adding to the value. And look, well, that was the program. This would be numbers. I print out numbers. Then look, numbers plus plus. You see what I'm saying? So
Yeah, I don't know why.
I know, but it is a pointer here though, because set is the what?
Right.
Array.
Right, they're setting it equal to the array.
To a pointer. So so if I do something like this, NUM, and then I would say I'll do up here, NUM is equal to numbers. All right, and then we'll use NUM and then NUM. All right. So yeah, so that's what it was, that address. So now it should, let me take this inline off of here. So now it's gonna go across and it's gonna give me the same value all the way across. All right.
You think it's because the array couldn't access that memory?
Right. Well, yeah, because the array itself, it don't want you to actually just do it against the array, but point it to a pointer variable. And because even when we did the function, it wasn't pointing to the actual array. It was that point. It was because we did a reference variable, which was a pointer variable. It wasn't the actual what? Array. When you pass it as an argument. Right. You understand? Right. So that's what it was. So if we run it, then this time, then you'll get, see, the same number across, but then this time what? Now this is the plus plus. So if you look here, first time through, it printed the dereference location of num plus 0, all right? So that's the 0 position is 10. Then we printed numbers sub 0. Number sub 0 is 10. Then we see out, like you said, we created our pointer variable called num. We assigned numbers, which is an address, which is an array, it's an address, and we assign that starting address to num. And then what we did, we outputted num, dereference it, that location, which is the beginning point, which is 10. Then what we did a num plus plus. Now, at this point, we done moved to the what? The next element, all right? Once we get here, X become 1, and then now we go to nums plus 1. So we print out 20. Then we print out number sub 1, which prints out 20, and we printing out that second memory location. All right, everybody see that? But remember with the num, if we did that address, with that num plus plus, by the time we got out that loop, we was at what element?
The 10th element.
Right, which means we was out, no, that 11 element, because we was outside, remember, outside the boundary, remember that? Because remember, yeah, right, so you got to remember that. So if you ever wanted to try to step down or whatever, so you got to remember those little things. But that's all your program was to do, was to go into your read, where you're reading in your for your loop and putting information in your array, change one of them to use this rather than Subscript, all right? And then that's the second program. You was to use this and put it into your array. And then the first program, you were supposed to use this method to put it into the array. Then when you printed out the data, you have to go to the to your print function, go to the loop, and just modify, your loop to where you're manipulating your array in this fashion and in this fashion. Everybody got that?
Yeah.
Now, with the sort and the search, now remember you was doing swapping and whatever and all that. So now you're dealing with having to subtract and add and all that. So it made it a little more complicated, all right? It made it a little more complicated.
That's what I want to ask you, if you could go over the bubble sort with array plus plus, because
All
I
right.
figure it out. I couldn't figure it out with pointers and without increasing the index or the element.
Without what now?
Increasing the index or the element.
Right, but you're increasing like this.
Right, but with the bubble sort, you're increasing it continuously. So I don't know how to do that. You see what I'm saying?
What you mean continuously?
So what I'm saying is, instead of having, let's say for example, you have dereferenced and then open parentheses, you'll have a pointer plus index, close parentheses, equal to a dereference, open parentheses, another pointer.
Pointer address, right.
Right, pointer address plus.
Because you're checking that value, yeah, okay.
Right, plus index plus 1. But I couldn't figure out how to do that. I couldn't figure out how to do that with array plus plus. You see what I'm saying? Like, I can figure out how to do it in the parentheses, but I know how to manipulate it with
plus. All right, let me see something. Because you always can assign your pointer, your address, remember? And then do it, yeah. So let me bring in a program with the bubbles. Let me see if I can bring in your previous. No. Okay. Now, this is the thing though. Remember, did you take your program? That was the second program, right? No. You had emailed me, correct?
Yeah, I did.
Right. Now, and I emailed you back. And what I told you, that the program says to take the previous program that had what?
The array program.
Array. Right.
All right, I got that, but I was wondering, I just want to specify if you wanted us to just, basically I was saying, do you want us to manipulate the bubble sort with array plus plus, or did you just want us to output it with array plus plus?
Well, see, you can't manipulate the entire array because it got processes in it. You understand?
Right, that's what I was wondering. I was
no, not that. Because when you assign values, you're gonna have to assign that address. And you got what I'm saying?
Right.
Yeah, no, you can't.
And I don't know if you remember. Nicholas Satoon. He took you a couple years ago, but I work with him, and he was telling me there's just no way you could do it. And
because you have to shift. You got to shift that address. You got to say, okay, I'm at the middle. Now I got to use this. Right. No. No. But what happens is when you actually referencing a value, like say if you're using a subscript to compare, do whatever, then I would want, that.
I get that,
right, yeah. No,
but the swapping part is pretty hard to do. I could not figure out a way with that.
It can be confusing, but once you get it, you're like, oh, okay, all right, okay.
Right.
Yeah. So yeah, but yeah, no, you can't step through. You can't step through that bubble sort. Like no.
Yeah, because I was wondering, because if you do array plus, say you did a array
right,
plus
trying
plus,
to go one at a time. You're doing select. You're doing a select. Right. Right. Oh yeah, no, yeah. I misunderstood that one. But I knew just take that first program, do that. Take the first program and modify it. Yeah. Now, how many people done my program? Hello.
It's not correct. I don't think now that we're discussing it more, but I definitely have done it.
All right. This is Mr. Who?
Mr. Massey.
All right, Mr. Massey. I don't know if you was online or when I was talking with Miss Bradford, and what I was telling her is we went over many different concepts of pointers, right? But I only chose those two to give an assignment because you could give many different, a different teacher could give a different assignment dealing with pointers to do whatever. But I just chose those two to show you how you can step through an array.
And I guess that's
Right.
where I was
You
getting.
understand? So that's why I said, that's why you gotta kind of understand concepts. Because just because a teacher go over all this stuff, then they give you assignment, and all assignment is references one maybe page of what y'all went over,
Right,
and
but
you like,
all that was
man, the
just-
teacher went over all this. I know I got to use this. I got to use that. I got not always. Now some do
Right.
now, but not always. But I just gave you those two to manipulate the array. Yeah, that's all that was. Yeah, that's all that was. Right. So, and like I said, I guess I'll have to how would I say it? But then you don't want to try to say, well, no, just do this. And then students are confined to say, okay, well, he just say use this and disregard looking at everything else in the
It's not
chapter.
disregarding, but it's kind of confusing when you went over so much.
Right. But all of it is dealing with pointers, if you understand. And understanding the concept of pointers. You understand what I'm saying? But I just wanted you to modify the program so you can see, well, I don't have to use my subscript. I can do it this way. Right or wrong? No, but you're dealing what? At a lower level, right? But it's all whether you choose to do it or not. All right?
We didn't even really touch the second half of the 9th chapter just because there's so much involved with pointers.
Right, there you go. It's just so much. Right. And then if I gave an assignment on every different aspect,
right,
we wouldn't even leave the chapter. Yeah.
And especially, like, I think pretty much everything C++ is pointers. So
right. Well, it's low level. C++ is a low level language. Right. Yeah. Low level language. Right. So, well, what I'll do, and just remind me at the end of class, I'll open up the assignments. I guess till tonight, and so y'all can go back and look over, modify them, and make sure they're in order. All right? Everybody understand? Right?
Yes, sir.
All right.
Yes, sir.
Okay. All right. So now, let's look at the next chapter. All right. First of all, let's look at our assignment. All right. So, and I do that so you can kind of understand what's going on. So you'll be like, okay, I need to remember this. Look at this assignment now. This assignment says using string functions, all right, and all other programming features discussed in the class. Write a program that will prompt the user to input their first and last name, all right? And an example, this is what I want to see. Please enter your first and last name. And example, they would input John Doe, all right? Once they input their first and last name, then I want you to output their first and last name. Now, class, this is the thing, and some people gonna send it to me, and they're gonna use two variables, and it's not in my program, but I mean in the instructions. But right here it says allow the what says it? Prompt the user to input their first and last name. What some students do is say input, and I'm just saying input as a pseudocode. Input first name, input last name. That's not what I want. I want one string to read in your first and last name. One string. Everybody got that? Now, if you took 193, you will understand that what? If there's a blank here, I cannot use CN. Remember that?
Right.
Everybody got it.
You can use getLine, correct?
You have to use getLine because if you just use CN, it's just gonna chop it off when it see with the first blank. So I'm giving y'all that little heads up. So you won't try to say, okay, I'm gonna do one variable and another variable, and I read them in. No, I want one variable called maybe a name, whatever you want to call it. I didn't give you any specifications on this one. So read in the name with one variable. Now, once you input that string, then prompt the user to input a nickname, whatever their nickname is. All right. Here, enter your nickname, and then they input it Rowdy. Okay, R-O-W-Y. I mean R-O-W-D-Y. Rowdy. Now, so you've inputted the person's full name in a string, and you inputted their nickname in a string. Now it says, then modify the string, all right, to consist of the person's last name, comma, nickname, backwards, in all caps, and closing double quotes, then the first name. Everybody see what I just did? Input a name, a first and last name, input a nickname. You're gonna have to find where that last name is, grab it, and store it in a string, a new string, store in a comma, store in a space, store in a double quote, and then store in the nickname in all uppercase backwards, store in a double quote, store in a space, and then store in the first name, and then print it out. All we're doing is manipulating string data, and we're gonna be dealing with our arrays and whatnot. Everybody understand that? Because a string is just an array, and we're gonna go over that. So plus 10 bonus, okay, if you do this, I'll put the first and last name, all right? Alternatively, every 2 characters. So I want this, all right? This is the regular program. This would be something else within that same program. If you had a person named John Doe, it would output J, the capital J, then the O from Doe, then the lowercase o. Well, man, my fault. No, let's see. Every 2 characters, excuse me. J-O, and then the D-O, all right? And then the N, which there's no other character, and then the E, all right? A person named Tim, the T-I, the W-H, all right? Then the M, and there's no other character, and then the E-A, and then the rest of the characters. Everybody understand that? All right. The program should loop. Now this is another issue you might have, because if you don't declare stuff properly, when you go back to redo it again, stuff go haywire. So the program should loop, prompting the user to decide whether or not he or she wishes to enter another name. All right. And this is the example. Do you wish to enter another name? So what happens? They input the name John Doe. They input Rowdy. They get the output. All right. Do you want to input another name? It should go back. You input a first name, last name. You input a nickname. Should give you output. Do you want to enter another one? It should continue until the person types in an N to get out, and then you could. You could do it. You could do this either way. You could do this each time you print out the name, or you could do it after you exit out the loop. It doesn't matter to me, as long as you can do the logic to where it manipulates this. All right. So that's the program. So what we're gonna do now, we're gonna go over some features that will help you to accomplish this task. All right, and that's back into the notes. All right. So if we go to the notes, all right, and the notes here is chapter 6, dealing with characters, strings, and the string class. All right. So, ma'am.
You say what chapter?
Chapter 10. What I said?
6, I thought.
Oh, okay. Unless I said string, I don't know. Yeah, but it's 10. Now, it says the C++ library provides several functions for testing characters, all right? To use these functions, you must include the CC type header file. You got to get that, class, or you'll be trying to fight, do things, and you never, getting errors. Like, it's kind of like when you first use string, and you tried to declare a variable as string, and you kept getting errors. Why? You didn't have the header file loaded for what? String. So now, in order to use these functions, all right, within the library, you're going to have to use CC type, all right? the CC type header file. All right. So now, these libraries provide several functions that allow you to test values of a character. These functions test single character arguments, okay, and return either true or false, either one and zero, on and off. All right. They actually return an int value of 0 for false and non-zero for true. So look at this. They have some example code. Char letter equals single quote, a single quote, lowercase. But then look, if is upper. Is upper is a library function, all right, that checks a character, all right, and now it's checking that variable, which is a character, to see if it holds the content of it is of uppercase. All right. If it is an uppercase letter, it will say letter is uppercase. If it's not, if it's either a lowercase, if it's a lowercase letter or any other character, like a special character, a quotation mark, or whatever, it'll say letter is lowercase. Everybody understand that? Everybody got that? You cannot make, well, we'll get to up or to lower, but if something is lowercase, then it's dealing with those characters, all right? Otherwise, you know, it is going to say lowercase. Everybody understand that? Because it's a character, but a question mark cannot be uppercase or lowercase, right? It'll just say lowercase, because what? Well, it can't be uppercase, all right? Well, it can't be lowercase, either one.
What does I supper represent there?
I can't hear you.
What does I supper represent there?
Is upper.
Is, yeah, that's is upper. Now, there's another function that say is lower. So if you wanted to test to see if the character was of lowercase, you understand? So if we look here, these are just a few of the functions, all right? You got is alpha. Okay, what is alpha? Alpha means any kind of character, not a number, that's not a digit, alphabet. You got what I'm saying? Alpha character. Because anybody have ever heard of the term alphanumeric?
Yeah.
Right. Alphanumeric means it's alphabets and numbers. And normally what? An address can be what? Alphanumeric, right? Or your L number is alphanumeric. You got what I'm saying? It consists of letters and numbers, right? But just alpha is just character data, all right? Or letters, not character, because character can get confused. It's just letters or alphabets, all right? Okay, is all num, AL num, all right? This tells whether or not it's alpha and numeric, okay? Remember I talked about alphanumeric? So if you wanted to just check to see if something was alphanumeric, as long as it's a character, as long as it's a number, you are right, all right? So it'll check it and give you an okay. Because sometimes what? You may want to check to see if something is alphanumeric. Then is digit. So now what? Now you're checking to see whatever's typed in is a digit. So and remember I told you, I think it was, I don't know if it was Mr. Gaddis, where we were talking about validation. And I said most times what they do in C++, they'll input everything as character, and then they'll apply these functions on them to make sure that they have, you know, the right type information so that the data can be accepted, right? Because if I just change something, if I make something num, even though you can use that man, what is that? And that's 193 class. Where you could change the data type and use it, and I forgot what it was. Cast. When you could type cast, you could have something declared as integer, and then I can typecast it as alpha, and then do whatever to check it to do whatever. You know what I'm saying? A character, and check it to do whatever. All right. Here is lower. That's the lowercase. All right. Is print. What happens is you have printable printable characters. Any character, like AB, 1, 2, all those are printable characters. But then you have non-printable characters like I think the \n, the \0, all those different characters, though they are non-printable characters. All right. So those characters you could check to see if they are, in your list of characters. Is a punctuation. So check to see if something is a comma, a question mark, whatever. Is upper and is space. Now, all of a sudden, now you could check to see how many spaces you have. So, in essence, we can take this information here, these functions here, read in or write a program to where we can come up with our rules for a password, right?
Right.
Because we could say, well, the password must be alphanumeric. Okay, so we could test that for alphanumeric. All right. Also, we could, well, then we don't have to use this one. We could just use alpha and digit, but we could use alphanumeric. But then alphanumeric might not give us whether or not it's a number or a character. So we might want to do the alpha, and then maybe we say, well, we need at least 2 characters. All right. So we need, when we go through alpha, if we go through the loop and the count is 2, we know that's satisfied. Digits, you might need 2 digits. Read through the password or whatever you checking against. If it's 2 digits, if digits equal to 2, like say you're checking each position and you find at least 2 numbers, oh, that's satisfied. And then where upper, you must have an uppercase letter. Then you check each digit and you find at least one that's uppercase. So see, and then if you find a space, it may make it wrong. So see how you can use these to actually create a password, a rule, and then when a person types it in, it goes against your logic. Huh?
Is this what they refer to as slicing?
As what?
Like slicing, like in Python?
In who?
In Python?
In Python, trying to what?
I'm not manipulate the characters.
They're doing what?
Slicing the characters, manipulating the characters.
Nah, because remember, a string is in an array. So you're still dealing with an array of characters.
Oh, yeah, you're right.
Right,
yeah, you're right.
right. So you're still dealing with an array of characters. So, and what happens is you checking each element in the array, because if I use the is upper, I'll check each position and have a count for upper. Like say, yeah. And if I find an upper left case, well, that satisfies that rule. Let me check for the next rule. It says I have to have at least two numeric two digits. So I'll check for digits. I'll say, okay, I found one. If I found the second one, I'll satisfy that. So you're manipulating it through arrays. Yeah. All right. So look at this and look at what they use here. So what happened is, this is just a program. Notice what's my header file. Have to use it. If I'm going to use the what? Is digit, is lower, is upper, is space. So char input. So that's what? 1 character. No matter what it is, it's going to input it. Whether it's a question mark, whether it's a backslash, whether it's a plus sign, whether it's a number, whether it's a letter, whatever you can input is going to receive it. All right. So cn.get. All right. And so we getting that value. Then what happens is it outputs the character, and then it checks if character, if input, if is alpha, for that input, then it's saying, well, it's alphabetic. Then it's checking is digit. Then we outputting it's numeric. And then we asking if it's a lowercase. Now, a number, like I say, wouldn't be an uppercase or lowercase. So it's lowercase, and then it's a lowercase. And then what? It's is upper. If it is uppercase, then it's uppercase. But then it asks, well, if it was just a space, which is that like a space between the name, or just hit the space bar and hit enter. If it's a space, so you can also check for spaces. A space would be a character or a position in a string. All right. So that's how you would use it. Now, what's going to happen is, now you see that they're using cn.get. what happens sometimes when you start using loops and you're coming back through the loop, especially when you're going from numeric to character data back and forth, the buffer does not clear, all right? And what happens, especially if I read in a number, it'll read in that number. Or if I say read in an int and I put in a float, I'll have information in the buffer and I won't have a chance to put in the information for that second input. Or if I read in a number, read in character, and then I'll go back to the loop and try to read in a number, it might skip that number because when I read in that character, it's going to read in the data and it's going to put a return mark at the end. And what's going to happen is that buffer does not clear, and then all of a sudden it takes that return mark and put in that next input, and then it skips that one and go to the next one. That's when you're going to use, and I think we did it in 193, that cn.ignore. But you got to know where to put it, because if you put it in the wrong place, it'll make you have to hit the enter key just to skip to get to where you need to get. But if you put it in a proper place, it'll automatically clear out the buffer. And then when it goes in to read that next input, it'll stop and prompt you and allow you to input that data. So you may run into that issue also when you're writing your program, all right? So let's look at this. Look at this program. Now, what this program is, what they did, they're just showing you how maybe if you wanted to set up some type format, say you're working with a company and you want to validate the type input for their ID number. You know, at BRCC, our ID number is what? 1 letter and what? About 8 digits, right? So if it was BRCC, it would be like L for a letter, and then 1, 2, 3, 4, 5, 6, 7, 8 ends to say a number, all right? Then our loop here, all right, well, how would I say it? Then what happen is they just telling you, and if it was BRCC, we would probably say, please enter 1 letter followed by whatever 8 numbers for your login, all right, or for your ID. And then you would read in that entire line of characters, right? But now look the size. So it give you a size here. When you look at this will read up to what? Those 7 characters. Cause look, 1, 2, 3. Well, no, it's gonna read the 8. But this is, see, now get line size. Okay, 0. Okay, that's right. 0 to 7. So 1, 2, 3, and then 4, 5, 6, 7. It's going to read in 7 characters. We made it 8. It's going to read in 7 because we have to leave room for the what, class? Begin with the letter N.
For the numeric?
No. How does it know that you're at the end of a string? What's that?
The null terminator?
Right. So you have to allow for the null terminator. Correct. Otherwise, it won't know where to stop outputting or whatever. So you're going to read in, you set it for 8. You're going to read in 7, and you're going to leave the space for the 1 for the null terminator, because it's going to be automatically added. So now what happens is you give them their format. Now this format says 3 letters and 4 numbers. Well, yeah, 3 letters and 4 numbers. So you read in the information, but look what they did. They put this in a loop to where they read in the first 3 positions, all right? So it says if test up number, all right, customer, all right, size, right, which is the size of this, which should be, well, it could be less than. If it's less than, that is an invalid number, because if it's less than whatever, the number is not valid, correct? Now, if it's more, what's going to happen, it's going to read and it's just going to cut it off. But you have to at least enter what? Your 7 digits, All right. But if you have your 7 digits, then okay, it's gonna come over here and says that is appropriate format. All right, here. Wait a minute. No. So this gonna call this function here, my fault. So you're gonna call say if test up number, where's number? Customer side, customer. Let's see where is that at. Here we go. See test number. See here at test number, what happens here? It checks the first 3 positions for what? If it's alpha. Gonna check to see sub count. Start 0 to less than 3, which is 0, 1, and 2, right? So it's gonna check the first 3 to see if they are letters. If it doesn't return false, or if it doesn't return false, then you know it's good. Then it's gonna check the next 4 positions, all right? But look where they start. For count is equal to what?
3.
So what they done? They did the first half, right? Or well, I can say the half. The first part from 0 to less than 3, but then now they taking from 3 up until the size, or the count minus the size, because why we have to do size minus 1?
To compare.
But what's in that last position? Remember what we said we made it 8 because what? No terminator, remember?
Right.
Right, so we want to check only the characters that was inputted. So 3, 4, 5, 6, and 7. Wait, yeah, 3, 4, 5, and 6. And so when we get out at size minus 1 at 7, you got me? And then the null terminator is the next one. So it's gonna check this. As long as this is true, then when it's gonna return, it's gonna get out and they're gonna return the true, and it's gonna know that what? It's a valid number, and then it's gonna print out well, really here it's gonna finish this, and then if it's not, you'll get this information showing what's the valid format. Okay? So yes.
Can I ask one question?
What's
the difference between C&ignore and system pause?
The system, all right, I'll tell you the difference in how they work. The system pause breaks out of the compiler and goes to a Windows operating system and executes that pause command. All right, now I'll give you an example. If I do, let's see. Ooh, there we go. If I do something like, if I want to find something. Let me see something. I need to find, wait. Go to D drive. All right, so see if I do a dr/p, see what that pause, see down here what the system did? Press any key to continue.
Gotcha.
So it's
that works in command prompt and everything else as well.
Right, correct, right.
Like,
now, the
like
thing is
PowerShell
though.
script would work?
Huh?
Like PowerShell script, would that work too?
But what it depends, because it depends. This is what I mean by that. If I run a program, a C++ program with system pause on a Linux system, I'm gonna get an error. Because when I break out of the system on a Linux system, what's the command to pause? What? I forgot the command. But there's a command to pause in Linux. You got what I'm saying? That's different from Windows.
Right, different OS.
That's the problem you run into when you do that system pause. It depends on what operating system you're breaking out into. All right. Now the
C&ignore would work in Linux.
Anything, but the C&ignore does more than the pause. the cn.ignore clears your buffer. It clears out the keyboard buffer, and anytime once that keyboard buffer is cleared, then if there's an input, whether it's a cn.getLine, whatever, it's gonna stop because it's waiting for information.
Right.
I could use a system pause, and my buffer, and if my buffer is not cleared, I'm gonna still skip my information. You got what I'm saying? So that's the difference in the two. Both of them are stop the system to say, okay, we're waiting, and then press a key or whatever. But at the same time, because if I keep putting a cn.ignore, 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 I'd have to keep hitting the key X amount of times until I clear those out too. You know what I'm saying?
You use just a CN with cn.ignore. You'd have to use a get line, correct?
But the thing is, that cn.ignore, you only need it when you're going back and forth from character to numeric data. Right.
Okay.
Right. Other than that, and now there's the parameters that goes with cn.ignore. You could cn.ignore so many characters. Cn.ignore, I think the whole line or whatever. So you could put a value. But normally just cn.ignore by itself defaults to just clearing out the buffer altogether. Yeah, but it is a difference. It is a slight difference. Yeah, and it can cause havoc. Yeah, it can cause havoc. All you got to do though, and if you're getting that problem where you're not able to input and you're going back and forth from numeric to character, just follow the flow of your program. Okay, I'm reading in a number. Okay, I'm reading in a character. Okay, where am I going back to reading? I'm going back to reading a number. So right after that read for that character data, put your cn.ignore. And then when it gets back, with looping back, it's gonna allow you to input that number. All right. So I can't hear you.
I said cool, thank you.
All right. So it tells us the C++ library provides two functions to upper, and we looked at them already, to upper and to lower for converting cases. And like I say, they just simple function. Yeah. All right. So what'll happen is if I do something like okay, I'll say equal B, and I'll do C out. All right. So if I do this, wait. I gotta put my. All right. So if I do this, wait. Oh, not B letter. My fault. All right. So now, if I do this, I'm not changing what let, and I'll do it again. See how. All right. And I'm just showing you, when I use these functions, I'm not changing my content of my variable. All I'm doing is telling it to represent it in a different way. All right. So if I run this, the first time it's going to take that letter B and it's going to print it in uppercase. But if I print out let, you're going to see that it's still in lowercase. It's down here. All right. Oh, no. Wait a minute. The first part, B is 66. Why is it printing out? And what it's doing is printing out the numeric value of it. How you do that? But it should have printed out the lowercase. But if you notice, the uppercase of B is what? 66, because the uppercase letter is 65, and the lowercase b is a higher number. But I'm trying to print out the B to show you. I could do this, but I didn't want to. Okay. Oh. Okay. Okay. All right. So what I did here, now I created a variable called letter. I'm saying letter is equal to upper let, and now I'm printing out letter. And it should give me that character value. I don't know why it's giving me the integer value. Okay, let's see. All right, so you see here, the first time I did it though, it printed out the what? The actual integer value. But what I did, I just created another variable and assigned to upper letter to equal to upper let. Let is B, uppercase B, all right? Then I printed out let here down here, which is the original. It don't modify it, it don't change it, it just change it in the representation of it. All right, but it doesn't change the content. All right. Now watch if I put a question mark. All right, it's just gonna give me the question mark. To upper, it's gonna give me a question mark. All right. So if I let me close this one up, and I'll run it again, because you can't uppercase a question mark. See what I'm saying? So letter is equal to question mark. To upper letter or let, it's just gonna be the question mark. It just returns what it is. It can't do any conversions on it. It can't do the uppercase. So it just gives it back as what it is. All right? Everybody see that? All right. So now, where am I? All right. So it just tells us to upper returns uppercase, to lower returns lowercase, without changing the value, all right? Without changing the actual value, all right, of the content. So if I do C out to upper A, it outputs the letter A. All right, well, it did it in with the double quotes, but I'll assign the value. Now, if an argument is already uppercase letter, it just return unchanged. It's already gonna stay uppercase, no problem. Any non-letter argument passed to upper is returned as it is, like we talked about the question mark. So if I do it to upper asterisk, you'll give me the asterisk. To upper ampersand, give me the ampersand. And so, any other character, when I say character other than a letter, will give me that value back. So to upper and to lower do not actually cause the character argument to change, all right? Change the stored value. So the stored value is not changed, it's just the representation of it or at that time is changed. So this simply returns the upper or lower equivalence of the argument. All right, char letter equal A, and then see how, this is what I tried and it didn't do it. I don't know why it didn't do it, but I had to assign it a value and then it worked. And then see out letter, and we got the letter. All right. So looking at this program, now you may see how and why it would be good to use to upper and lower when you're asking for a yes, no answer or something. Rather than prompt the user to input capital Y, lowercase y, or capital N and lowercase n, all you have to do is look here. While to upper, and go again would be the choice. Go again equals Y. All right. So I don't have to say uppercase or lowercase. If they put a lowercase, it'll take it, put it as upper, and check the value. You got what I'm saying? And again here, if it's Y here or if it's no here. All right. Don't have to ask if it's uppercase or lowercase, or if it's uppercase or lowercase N. All right. So it kind of eliminates a lot of other coding for you. All right. But if you notice, this is a program. Now, what I told you, your program that you write, you need to what? Allow the user to what? Continue, be prompted to see if they want to continue with the program. If you look at this logic down here, right? This logic down here is what you can use to perform that logic. Now, class, this program, I don't think we using functions, all right? So we done broke away from functions for a little while, all right? So you don't have to use functions in this assignment that we have with the name and nickname. All right, but like I said, look at this. Calculate another, yes or no. CN and go again. Remember, that's the choice. So when you input that, then what? While to upper, go again, which is the choice, is not equal Y or not equal no. You're gonna keep prompting them what? Please enter again, a yes or no. So it won't go back and execute everything and ask please enter. It'll just stay prompting you, please enter, yes or no, until you enter a Y or N. Any other character, it'll stay all in this loop until, and this is like this loop here. It'll stay in this loop here until you enter a Y or N. And then once it get out and it see Y, it goes back and execute again. If it's no, it kicks out. All right. So like I say, that's logic you can use. But in this program, it just did calculated some figures, what it did, the radius, all right, or the area of a circle or something. So that's basically all it did. Cn pi, then pi is equal to radius times radius, which is radius squared. All right, pi r squared. So all you found was the area of a circle. All right. So, and then what? It allows you to prompt the user again to input another value to see if you want to do it again. All right. But in this program, you're not going back from character to numeric character. Well, you are. You are going back from character to numeric. Let's see what happens here. Radius Cn, but there's no Cn dot ignore. Okay. Once you input this, and then you're going back here. And so, and then this program might see where you may need the Cn dot ignore, because you're going from numeric data, then you're going to character, but there's a single character. So you don't have null terminator, my fault. When you have the double quotes, that's when you have the null terminator. And you may run into those issues, all right? So that was the char data. All right, but char data can be considered string if it's in an array. We'll get to that. All right, and we'll look at that later. All right, strings. All right, string is a generic term that describes any consecutive sequence of characters. Because really, string is not a data type in C++, but they have function built so that we can use it as a data type. All right, so any series of characters could be a series of numbers. That could be what? A string, right? Depending on if we declared it being of string, right? But any series of characters, a word, a sentence, person's name, a title of a song. Example, have a nice day, enclosed in double period, enclosed in double quote. That's a string, right? A string may be constant or variable in nature, right? It may be stored in a variety of ways, all right? C-string describes a string whose characters are stored in consecutive memory locations, all right? Like arrays, consecutive memory locations, right? And are followed by a null terminator. If you do not have the null terminator, which some of you all may run into that issue with this program you're writing, all right, where you're gonna may have to put the null terminator at the end, whatever, depending on what you're doing and how you do it. You're gonna see how your program gonna still loop if you're looking for the null terminator or if you're looking for such and such. All right. So the null terminator ends the string. That's where the system knows, okay, I need to print from here to here. Because if you ever notice in with strings, all right, if I do something like this, if I do pound include string, and I'll do something like take this out. All right. So I'll do something like this, and I'll do something like see how. All right, enter your full name, then CN. All right, I can use CN. Yeah, or just a small one, but I'll do CN name. All right. Now I can control, like I say, what I read in. I could say 30. So anything beyond 30, hey, is disregard. All right, or 29 or whatever. I could tell it or 20. You know how many characters I want to read. All right, so 30. So now, then what happened to see and not get line with him here? What happened? What happened to see not get line? No. Why am I still not getting line now again? Still not get. But this shit I could use line. Still not get. Oh. Should be 30 though. Should not get line. Well, that's not working. All right, let's see something. Still not get line, whatever. Then I could say here, see out. And all right, same name. Well, I'll tell you what, I'll use a CN right quick. CN, but like I said, it's just a simple program. So CN name, okay. I'll take it out. I wonder what's happening. CN name, I should be able to read a name. Oh, all right, yeah, there we go. What happened is, and you got to look at it. A string is a what, class? A string is an array. When I put 30 on name, I said I have 30 different strings. Everybody understand that?
Mm-hmm.
That's not, because just string name is going to be a string. How long is a string can be any length. So just string name is already a string, all right? How many characters, you don't know. But now, if I put 30, that means I'll have 30 strings. But I didn't want that. I just want string name. So I could do CN, or I could do the CN.get line to grab the entire line, all right? CN. All right. So now, no, it still didn't. But it still should have. Oh, 29. What? Not working
I
on.
have a size declared for name, so wouldn't you not use the extension of the size?
What happened now?
You don't have name declared as a size, so wouldn't you?
No, but it's just a string.
Right.
So I should be able to just read it. You know what I'm saying? And tell it how many I want to read. Even name. So if I do CN, even if I and take this off. All right, I'll just read it this way, and I'll look up that CN. Read in name. Now, But see, when I do it this way, get line. I'm gonna do the get line. All right. Do it this way. All right. That's gonna allow me to read what? The whole name, first and last name, correct? Because if I just use the CN, it's gonna stop on the first time it hit a space. So now when I output, and notice, this is what the point I wanted to make. The name is a string, correct?
Yes.
I could put in 20 characters, 30 characters, 10 characters, 2, 5, whatever. Why don't I have to manipulate each individual character to print it out? Like I do with a numeric array. See, remember with a numeric array, I got to put it in a for loop and say what? For x equal whatever, 0, x less than whatever, and print from the first one to the last one. But name is a string is an array, so why shouldn't I have to do it here? Remember we talked about that what? Null terminator, right?
Right.
So when we type in our value here and hit enter, it automatically assigns that null terminator, so it knows what? I'm gonna start at the beginning and end at the null terminator. So when I run this, all right, and I put in whatever, okay, I put in John Doe. When I put that in, hit enter, see it took in John Doe up until here, all right? So if I would have just said CN, then that's when I'd have had that problem. CN, if I'd have just did, I ain't got no errors, but what happens is now I'm limited to just one character up until the space. See, it just outputted John. So you got to be aware, but it will read up until that null terminator, all right? So it will go up until the null terminator. So look at this. It says, a string is consecutive memory locations followed by the null terminator, all right? Now, the null terminator marks the end of a string. Without it, a function has no way of knowing the length of the string, our argument. All right. Now, let me show you this. So you have your null terminator. So watch this. If I told you to read in a name, all right, and I'll go back to the get line to this one. I mean the CN. Yeah. All right, this one. If I told you to write out the name, all right, how would I say it? I wanted you to write out the name and stop at the null terminator, but I wanted you to output it character by character. You can do something like this for x. I could say x equals 0, not x. Yeah, x equals 0. And I'll do something like this. I'll say, sure, let equals all right. So now what? I'm assigning this value to equal what? Null terminator, right?
Right.
And while that is that, okay, x is 0, and name sub x not equal so what have I just done here, class? And what I'm going to do...
It's going to output each individual character, and it's going to end on the null terminator.
Correct. So I'm gonna start with this because what? That's gonna be my index to manipulate, go through my array, right? But I'm gonna ask each time I go through it, which is my strength. Each time I go through it, if name sub x is not equal to null terminator, I want to do something. So what I'm gonna do, I'm gonna just do C out. I'll do /T, and then I'll output name sub X. Just to show you that it's actually an inline. Now, what this is gonna do, put each character on a line by itself, right?
Right.
So now, when I run it, and we'll go back and look at the program once we run it. It's gonna ask us for a name. Okay, John Doe. See what happens? What it did. Okay, we said enter a full name. So we enter John Doe. Now, once we enter John Doe, we assign created a variable called let, right? A char value, and we made it equal to what? The null terminator. \0 is null terminator. It's a character in the string. That's how you know you're at the end of a string. So now, in this for loop, we said for X is 0, because if we want to print out each individual element in that string array, or in that string, you have to start at the first position and move on. And we said what? In computer science, it starts at 0, right? So we're going to start at 0, and we're going to go until name sub X, okay? This is name sub 0, sub 1, sub 2, sub 3, sub 4, sub 5, sub 6, sub 7. So, and then we got the null terminator. So we're going to go until name sub X, as long as name sub X is not equal to the null terminator. What we want to do, we want to output the name, all right? Or output name sub X, that single character, all right? So the first time through, X sub 0, name sub 0, J. Add 1, name sub 1, O. Add 1, name sub 2, H. Add 1, name sub 3, N. On and on. Then you got the space, you got the D, you got the O, and then you got the E. But you got what? Space, space. That's where this comes from. That's not spaces in the program. That's 2 lines that we added at this point. So any name I put in, it's going to do the exact same thing. So when I run it, it's going to go up until another term. If I say, I'll just say Baton Rouge, just for name, Rouge community. See what happened? All right. Baton, Rouge, community, college, and then null terminator, and then it printed out from beginning to end for that last one. All right? Everybody see that?
Yes, sir.
All right? So now, if I wanted to print just the first name, right? Or either store the first name into another array. I could take each individual element and put into another array, right? But let's say we want to just read the first name. All right, I'll do this while not equal to what? A space. Correct? So now, no matter what I put in, and like I say, I'll let it go down. All right, I'll let it go down still. When I run it and I put in John Doe, it's just gonna print out what?
Just John.
Right. See what I'm saying? It just print out John because I said from X equals 0 and then name sub X not equal space. Everybody got that? And I'm giving you these little tidbits because what? When you're writing your code, you can say, okay, well, I want to take the first name and put it into an array. All you'd have to do is create your another string, like say, right? And then what you can do here, and I could still do the C out. I could do equal. Now watch what happens here. Now, let me ask you something. Now I'm taking first name sub X, name sub X and putting in first name sub X. That's cool, but what am I missing here? Anybody could tell me.
Null terminator?
Bam! But you understand? So you got, I don't care what string you have, it has to end with the what? null terminator. So outside of here, I can do what? I could do X plus plus, and then what? My fault. Right? So now what I can do down here is C out, and then I'll do /T, and then I could do what? Just F name, right? I got this wrong. Because it's gonna print from the beginning of first name to the end of the null terminator. Oh, whoa. Ah, that's because of this scope here. So what I need to do is, I'll say, I'll do X equals 0 here. X equals 0. Okay. I just could say X, cause, okay. And then that'll allow this to be in the outer scope. Everybody understand what happened. When I did int X in here, the scope of X was only in here. If I do int X in outside in the main, then I can use X. When it jumps out of here, I can still use that value. All right, so that's all that was. So now I run this, and now, oh, it's down here. All right, so I type in John Doe. Oh, I got an error. I have an error. What did I do? Let's see something. For X equals 0, name not equal space. Oh. I'll say I'm gonna do null terminator. Because I wanna go all the way to the end. All right, let's see. I think that'll fix my problem. I'm not sure. All right. Nope. And telling me what? Expression string subscript out of range. Okay, let's ignore. So I'm out of the range. So I'm in this for loop. X equals 0. Ah. Oh. It's here. I think it's here. But still. Name sub X. It's in this. First name string. I don't have. I'm gonna say. Well, you shouldn't have to do that. I think it's trying to work with but it's still not right. I don't think that. Let's see. See, it's my string for my for this, but I don't know why, because this
Is it
isn't.
because you're incrementing X, then you're trying to use F name outside of the loop? So it's trying to go to the next position.
Yeah, but see, but it, this only stays in here. You understand? Mm-hmm. So that's gonna increment until this. You see what I'm saying? And then it comes out increment by 1, so I could put the null terminator. And let me see. And I think it might be this size, but it shouldn't. That means I'm gonna have to give it value. I don't want to have to do that. Let's see. Yep. See, that's what it is. For whatever reason, this string, just declaring it as a string is null, is nothing. So when I'm trying to add to it, you see what I'm saying? Because what? Where name is given what was inputted here, so it has a size. When I just do the string here, it don't have nothing in it. You got what I'm saying? So when I try to add to it, there's nothing. There's nothing available. So what I did, I gave it a empty size large enough to manipulate the string here.
Right.
Yeah. So that's what happened. So what happens here though? But this one went all the way to here. I need to say if though. Because see, it's gonna equal to John Doe. And I don't want it to equal to John Doe, the first name. See, first name is John Doe. All I would have to do is here say if name sub X is equal to space. Well, not equal to space. Right. But then I'd have to have another thing with and whatever. Because I could do not equal to space, all it's going to do is take the space out. You got what I'm saying here? But I'd have to say and I'd have to catch that size of the space and X is less than that index of that space index. Because I don't want to add nothing else after I pass this. So I could say if name is not equal. Well, I could go back to this and say space. I think. All right. Being that I have the other one, but I still might get a debug. Let's say debug. It's just gonna give me what in name, which is right. See, I got the error. Ignore. See, I'm getting the error because I'm going all the way to the space, and this. Yeah. So that's what's gonna have to happen. Name is this. Well, this is not equal to space. I'll tell you what. Yeah, you just changed this for to a while. Yeah, just change that for to a while name sub X not equal whatever. And that way it's just gonna do up until the space. And then you could do the X plus plus. X plus plus. And then so it's gonna go through, and then add one, and it'll just give you the name. All right. So that should work. I'm using the for when I should have used the while. All right, because we started out using the for. All right, so when I do this, wow, I got an error. Where's my error? Variable X. X is here, and X. Equals 0. All right, so I run through this, and then we get back to the notes, and then I'll put John Doe, and it should just give me John. See, the whole name was put in John Doe. The loop was processed with just John, up until the space, and then the first name is equal to John. All right, but then we're gonna go over some other stuff where once I have first name equaling to John, you could take that and start using some other string functions to concatenate and whatnot into a bigger string. All right, so now a string literal or string constant is enclosed in a set of double quotes. Like I said, we just saw that. Okay, have a nice day, enclosed in double quotes. No terminator automatically added. What is your name? No terminator automatically added. John Smith. No terminator automatically added. All right, any one of those. All of the program's string literals are stored in memory as C string, with the null terminator automatically appended. Okay. So now, character functions. All right. So here we have this program again where we asking if it's uppercase or lowercase y. But we know we can what? We can use what? The to upper to where we can check to see if it's lowercase or uppercase. But you can do it this way also, okay? So it says, although, talking about these strings here, although the strings are not stored in an array, these here, they're in the double quotes, all right? They are still part of the program's data. The first string occupies 30 bytes. So from here to here is 29 characters. But what happens? It adds the null terminator at the end. All right. The second one, 39 bytes. All right. Not from there, from within. I don't know why it's grabbing the double quote with the space. Okay, yeah, from here. So from here to that space, all that's 39 characters. All right. And the null, both sizes includes the null terminator. It's added automatically at the end. All right. So now this is just somewhat of a representation. How would I say? Just a pictured representation of how data is stored, on the disk or whatever. Each individual byte has its position. Okay. The space has a position or byte or location, and all of the information. And at the very end, a null terminator. All right. Same thing. Do you want to see me see the message again? ? Space. Same thing. In consecutive order with a null terminator. When you output this, the system sees this and goes through these consecutive memory locations and say, I'm gonna print till see a null terminator, stop. That's how it works. All right. It's important to realize that a string literal has its own storage location. All right. Just like a variable or any array or an array. When a string literal appears in a statement, it's memory address that C++ uses. All right. So it uses the address, starts here and stops, at the null terminator. In this statement, the memory address of the string literal, do you want to see this message again? ? Space is passed to the cout object. The cout displays the consecutive characters found in the address, and then it stops when it sees the null or encounters the null terminator. All right. So here we go. String stored into an array. So what they use? What the data type they use?
Char.
They use char. All right. So when defining a character array to hold a C string, be sure the array is large enough for the null terminator. All right. So make sure it's large enough for the null terminator. All right. Now, and what I could have done in the program, and I'm not going to do it, I could have made this char. You understand? But if I would have made it char, then I'd have to make this an array. You know what I'm saying? Make this char, make it an array, and I have to make sure that the array size is large enough to hold what? The values that I'm gonna put it in, plus the null terminator. You understand? Now I can make it larger. And always what? The null terminator will signify what? Where to stop printing. You know what I'm saying? I always can make it larger. And I could put in 2 characters and put in a null terminator right after the second character. It'll know when to stop. But the array has to be large enough in order for it to do what it needs to do. All right? So, and this should work the same as that previously. So let's go back to the program. So now, it says that given this char company 12, that means the variable company is a char array. It can hold 12 characters, but that last character has to be the null terminator, or it has to be how would I say, the maximum number of characters can be 11, and the 12th position, or the 11th position, the 12th position has to be the null terminator if you have 11 characters in it. All right. So now, string input can be performed by using the CN object. Okay, it allows strings to be encountered, to be entered that has no white spaces. All right, the CN object into the company array. If the user enter more than 11 characters, CN will write past the end of the array because what? It has no way of knowing the variable company has 12 elements. So what happens is when you do a CN company, we set this at 12 and we put in 15 characters, all of a sudden it's gonna try to print and it's not gonna stop. It's gonna keep reading them consecutive bytes until it finds a null terminator. And that's how sometimes you get those special characters and funny characters in your output when you're dealing with string data and character char arrays and whatnot, because you went past the null terminator, or there's no null terminator, and it just kept reading memory spaces a byte at a time, and it brings up gibberish. All right, so you got to be aware of that. So, did I use this one? I did use CN.getLine, but I used it with string, not char, right? So the CN problem can be solved by using the CN's getLine member function. All right. So with char, all right, they use line, and line is an array of really 79 characters, with the last one can be the terminator. So the max size can be 79. So what happens is you do the CN.getLine and then the variable or the array and the char array, and then you can specify. You can say 20, you can say 10, you can say whatever. So that's gonna allow them to only accept those characters. And what happens if they put more, it's just gonna accept up to those characters. All right. So you gotta be mindful of that when somebody using the system that you create when you're writing in C++. So C++, well, not C++, CN will read 79 characters, or up until 79 characters. It'll read 2 and put the null terminator after those 2. It'll read the 79 characters or until the user press the enter key, okay, whichever comes first, all right? CN will automatically append the null terminator for you, all right? So you don't have to worry about that, all right? So looking at this small code here, let's see if I can kind of put it where all of it along the screen. All right, so it says this program displays a string stored in a char array. All right, I did the string, but look, what happens? They did what? They have a constant size of 80. All right, they created an array called line with the size of 80. All right, it had count. Remember, I had to take. Well, no, they did the while loop. So they did the while loop. So they created an index called count, with your subscripted variable called count that will start at 0. All right. So because you can't really fall in the loop here and talking about line sub count, and count doesn't have a value. All right. So what they did was said, please enter a sentence with no more than size -1, which is 80 minus 1, which is 79 characters. And then so if they enter more, they're gonna be disregarded. So CN.getLine, CN.getLine, line, which is the array, and then the 80. All right. So it'll accept those 79 characters and put the null terminator in, or it'll accept 10 characters. And when you hit enter, it'll put the null terminator where you hit enter, where the cursor is. So the sentence you entered is, and then what they did, while line, which is the array, sub count start at 0, is not equal to, which we did in our example. What is this, class?
Null terminator.
Null terminator. How many characters is it?
1.
1 character. It shows 2, but it's 1. Now you can how would I say? You can rationalize that by if you in C++ knowing what? If I got single quotes around something like this, and it's not giving me an error, then that's what? A single character, correct? So
Yes.
this is the null terminator. \n, \0, \r, \a, all those are single characters, right? So now, as long as we're not at the null terminator, like we did in the program I showed you, it's outputting each individual character. But what? Output the character, but I have to increment my index to jump to the what? To the next array position. Print that character, jump to the next array position. So if we look at the program that we was working on, what we really did here, and like I said, I changed it to char. Char, first name 20. All right. We didn't do the get line. But if you look here, name sub x is equal to f name sub x. So I'm putting that into that, going back through, putting it into, going back through, putting it into. And then when I get to the end of the name, going down out of here, increment by 1. And then and do I need to do it? I don't need to do this anymore because I'm adding a space, right? Because each time I add it, I'm incrementing. So I don't need to increment again. Because what I'm adding is a blank space, correct? Everybody see that? Everybody understand that? I commented this one out. When I had a for loop, I was incrementing when I returned back to the top. Being that I have a while loop, I output, then I increment. So once I fall out of here, I've been incremented by 1. So I don't need to have this in there anymore. So it keep adding, keep adding, keep adding until it actually finishes. So this should work, okay? And so if I put John Doe again, see? And first is John. So what happened is, all right, now I didn't use a CN get line because I had string up there. I read in a string, all right? I did the get line CN, all right? But the first part, it printed out each individual character on a line by itself. That's this line. This line here stored each individual character in the first name array. So when I printed John, then I stored J. When I printed J, I stored J in the first name. I printed O, which is here, then I stored O in the first name. I printed H, then I stored H in the first name. I printed N, then I stored N in the first name. Then when I got out of it, I added the null terminator at the end. All right. So now let's do this for sake of research. I'll take the null terminator off of here. All right. Right. Let's see what type of output we get. Now you're going to see. Now I don't know what type gibberish we're going to get. It depends on what's all after that array. So I'll run it. Okay. And I'll put John Doe. Look what happens. See what happens? The system really does not know what was beyond John, because what? We stored the J, we stored the O, we stored the H, we stored the N, but we didn't store nothing else so the system gonna keep trying to read up until those 20 spaces, right? Because that's the array size, and what? It printed out this information here, which it just pulling up names sub 1, sub 2, sub 4, sub 5, sub 6, sub 7, all the way to sub 19. All right. So it just pulled this in, all right, which is, like I say, is garbage. All right. So see what happens if I don't put that null terminator in there. It does not know when to stop. So it tried to print the whole array. All right. Tried to print array of 20. And if I change this to 40, it'll print up to 40 different characters. All right, because I'm trying to print the entire array. I didn't see a null terminator. Okay. All right. So what happens here? It reads in a line, whatever you type in. Then it displays the line. It says while line subcount not equal to The null terminator C out there. I could put any character in here. I could put a capital B. I could put the O. I could put a C or whatever. Up until it's equal, it's not equal to that particular character, I'm going to continue to output my line, right? So, like I say, but this says up until the end of the string that was inputted when I hit enter. All right. So here are some other type functions that can be used with C string. All right.
Mr.
C plus.
Sylvester,
Yes.
it's almost noon.
I'm still talking. Yeah. All right, man. We'll I'll just what I'll do, I'll post the assignment, but not assign it because we're gonna go over this. These are some of the functions that I want you to use to along with using your arrays and whatnot to manipulate or to do your program that you're gonna be doing. String cat, string copy, all right, and stuff like that, right?
Roger.
Okay. So we'll start on this on next class period because I got another class. I'm sorry, y'all. I was going on and on and on.
Don't forget to open up the last 2 programs.
Oh yeah. Oh, see, I forgot. So I'm gonna open them up so that you can work on them tonight. All right. And I'll just open this one up so you can view it and work with it. All right.
Okay.
Understood.
All right. I'll see y'all on next class period.
All righty.
See you, Mr.
All right.
Sylvester.
Bye-bye. Yes.
No, I just said see you. Sorry.
Oh yeah. All right. Have a good one.
Good day, sir.
Huh?
Have a good day, sir.
All right. Have a good one. I'll see y'all. Try to get in my other class.